All right, today we are building off of what we learned yesterday. It's similar but different, okay? Similar but different. This technically is something new. I haven't taught you this before. Technically, this is on our notes today. It's not, it's right here, but it's not hard. This is the easiest version, I think, of what we were doing, okay? A little bit different than what we've been doing with composition because one is sine and one is inverse cosine. It's fine. We can do it, no problem. So sine of 5 pi over 4. That's just doing that. What is the sine of 5 pi over 4? So we're thinking on our unit circle. Sine of 5 pi over 4, it's down there. If I'm doing sine of 5 pi over 4, Jack, what's that going to get me? Yes, sir. That is negative root 2 over 2. That's just the y value at that ordered pair right there. And then we're doing inverse cosine. If I'm doing inverse cosine, Matthew, which quadrants are we thinking about if we're doing inverse cosine? 1 and 2. So I'm thinking in quadrants 1 and 2. When is my x going to be this? Earlier, a student needed me to write this instead. So cosine of theta is equal to negative radical 2 over 2. That is the question we're answering. When we see this right here, we are answering this question right here. When is your cosine going to get you negative radical 2 over 2? Anybody? That is at 3 pi over 4. That is that ordered pair right there. If you look at your unit circle right here at 3 pi over 4, oh yeah, my x is negative radical 2 over 2. And it's got to be in the second quadrant based on what we're doing. Make sense on the first one? Sketch a graph of tangent compared to cotangent. Okay, so I'm going to cheat here. I'm going to use Desmos just to save us some time and some my graphs are ugly idea here. So if I graph tangent, tangent x, I'm going to change the scale. Pi over 2. What quadrants do we look at for inverse tangent? 1 and 4, right? Our answer is between negative pi over 2 and pi over 2. X equals pi over 2. Look at that graph. Yeah, that makes sense. We're centered at 0. The reason we look between negative pi over 2 and pi over 2 is because we get a full continuous cycle. Everybody understand what I'm saying with that? I got a full curve in between there. I could pick other values, but in between those two, I'm going to get a full continuous cycle. Now let's think about cotangent. Okay, there's my cotangent graph. Does it make sense to go between negative pi over 2 and pi over 2 for a cotangent graph? No, because if I looked at that, so I'm going to restrict it to that. So negative pi over 2 and pi over 2. That's what I would get. That's not a full continuous graph. We get this undefined thing in the middle. So that's not what I want to be. In between, which two values should I be instead to get a full continuous cycle? 0 and pi. Because if I go between 0 and pi, oh yeah, I get one full continuous cycle. I go all the way to the top, all the way to the bottom. So which two quadrants are we looking at if we're doing cotangent? 1 and 2. I'm between 0 and pi. Kind of makes sense? All right, good. That's important to understand. So we kind of identified that, and we'll do more here in a second with it. What about this? Talk with your neighbor for me. In between what values can you get a full continuous cycle of secant? All right. So as I was walking around, somebody said, I need a full up and a down. That's a full cycle for us. Okay, an up and a down. So in between which two values can I get a full continuous cycle? Anybody got an idea? Negative pi over 2 and 3 pi over 2. Oh, I did that wrong. Sorry. Is that continuous? No. And so I get, so that didn't work. When else could I get a full continuous cycle? The answer is never. Okay? You can't do it. Same thing would be true with cosine. There's no, or cosecant, sorry. There's no way to get a full continuous cycle. It just doesn't happen. And so instead of worrying about that, we are going to model with the same quadrants that our other ones did. So with cosecant, between negative pi over 2 and pi over 2, we're now hitting every value that we could hit. Okay, every y value. It is a one-to-one function. Okay, and so that's when we're going to do the inverse. Yeah, it's not continuous, but I can't make it continuous. Same thing with sine, or with secant. If I'm doing secant, I don't have an up and a down if I use those, so instead I'm going to go from 0 to pi. It's a one-to-one function. It's not continuous because I can't be, but at least I'm one-to-one function. We'll do that here in a second. All right, that's a little bit strange, but it's a good thought process. Let's go to here. You have a question? Yes, so the asymptotes are not gonna make us continuous. That's why cotangent we decided to be between 0 and pi, because we are able to do a full cycle without an asymptote in the middle. We can't do that with secant and cosecant. There's always going to be an asymptote in the middle no matter what we do. Yes and no. Yes and no. I'm not too worried about that right now. All right. Good thought. Here we go. Example 1. We are doing composite functions again. It looks a little bit different. All right. So find the exact value of sine of inverse tangent of 1/2. So think about what this means. You're asking the question, figure out, I'm going to write this in words just because. Don't write this in words. Figure out the y value. That's the sine part. Figure out the y value when tangent is equal to 1/2. That is what you're asking here in awful language. You would never want to write that out. But that is the question we're trying to answer. Figure out what is the y value when tangent gets you 1/2. That's what that's stating. Well, what angle is tangent going to get me 1/2? Do we know that? Based off our unit circle knowledge, do I know exactly when tangent gets me 1/2? I don't either. We know when tangent can get me 0, when it can get me 1, when it can get me radical 3, when it can get me radical 3 over 3, but I don't know when it's 1/2. The good news is I don't really care, because all I want to know, I don't care what the angle is, I want to know what the y value is when this is true. And so when we see this, inverse tangent is 1/2. What I'm going to pull from it is the x, the y, and the r. That's what I'm going to pull from it. That's going to tell me the information about this angle. So if tangent's 1/2, what does that tell me? Y is 1 and x is 2. Are they both positive? Or could they both be negative? Maybe, but they're not. How do we know that they both are not negative? It's inverse tangent. And inverse tangent is only going to live in quadrants 1 and 4. And 4 would be negative. So it's got to be in quadrant 1. So they both need to be positive. Okay, so I've got my x and my y. How could I find my r? Pythagorean theorem. X squared plus y squared equals r squared. Oh, x squared, 2 squared plus 1 squared is r squared. So 5 is r squared. So r is root 5. So the question was, figure out the y value when tangent is equal to 1/2. And so basically what we are deciding here is the angle. My y is 1, my x is 2. So my x is 2, my y is 1. It's this spot right here. That's the place on the unit circle, or on this circle that we're describing. That's the angle. Okay, this r is radical 5. All I want to know is the y value. I want to do sine of that angle. Well, what am I going to do to figure out sine? Sine means y over r. I don't really care where it is on the unit circle. I just want this information right here. Sine is y over r. And so my answer is going to be 1 over radical 5. Some of you on your last test left it like that. Don't leave it like that. What do I got to do? Rationalize it. Multiply top and bottom by radical 5. My answer is radical 5 all over 5. So it's a weird question in that you're doing some different things. But when they tell me inverse tangent is 1/2, they're telling me all the information I want. They are telling me my x and my y. It allowed me to find my r, and then based off of that, I can figure out what sine is going to be. Kind of makes sense? It's different. You got to think about it. Use your brain. That's what this chapter is all about, or at least this sections are. This is not something you're going to do on your job. You are not in your job when you become a banker or where you own a business. Are you going to have to do sine of inverse tangent of 1/2? But you're going to have to think and use logic and try to work your way through the steps. That's what we're building more than anything else here. Okay, try the next one. Find the exact value of cosine of arcsine of negative 1/3. Think about it. Think about quadrants here. See what you can do. You and your neighbor. Go. Let's go. We're looking at this thing. Find the exact value of cosine of arcsine of negative 1/3. So what it's asking you is, where is sine negative 1/3? I don't know. But I don't really care, because all I want from that is, what is the x value when that is true? And so the best way to approach this thing is to go x, y, and r. Okay, x, y, and r. As I look at that thing, what can I pull if it's telling me I'm looking for arcsine of negative 1/3? Kara, what can that tell me here? The y and the r value. The y is 1. The r, which one's going to be negative, y or r? The y has got to be negative. R is never negative. I'm doing arcsine. So which two quadrants am I living in if I'm doing arcsine? 1 and 4. Which quadrant am I specifically living in if my y is negative? It's got to be in quadrant 4. This is describing an angle in quadrant 4. Okay? So to find x, we're doing Pythagorean theorem. X squared plus 1 squared equals 3 squared. Notice that I don't even write the negative 1 because I'm squaring it anyways. X squared plus 1 is 9. So x squared equals 8. X is going to be equal to plus or minus 2 root 2. I simplified the radical. The square root of 8 is 2 radical 2. Which one do I want here? It can't be both. Is it going to be positive root 2 root 2 or negative? Why? I'm in quadrant 4. If I'm in quadrant 4, we made that decision already. If I'm in quadrant 4, it's got to be the positive version. And I did all of that. I got all of that from this right here, from that arcsine is negative 1/3. Now I'm just figuring out the cosine. Oh, cosine means what's the x value? What's the x over r? So my x is going to be 2 root 2. And my r is 3. Boom, there's my answer. Questions on 2? You'll get the feel for that. It's a little bit strange, but we're pulling that information from x, y, and r. Okay, let's go down below. Let's talk about our 3 new trig functions for the day. We're doing the inverse of the reciprocal functions. When you think cosecant, and this is what we did in bell work with that Desmos kind of working through. When we think cosecant, what function are we thinking about? Sine. And so when we do cosecant, we're just thinking sine. We can get a continuous function. So we're just going to use the same values as sine. So which 2 quadrants did we live in for sine? 1 and 4. And so what that means is my range, my answers are going to live between right there and right there. So my range, I'm not even going to talk about domain, but my range is going to live between negative pi over 2 and pi over 2. That's where my values are going to live. I'm living between those two because cosecant, we're just using the same rules as sine. If we're doing secant, which function are we thinking about with secant? Cosine. Which 2 quadrants are we living in if we're doing cosine? 1 and 2. I'm living in 1 and 2 if I'm doing cosine. So I don't really even care about domain, but my range is going to be this guy to this guy. So it's going from 0 until pi. 0 to pi when we're doing secant or inverse secant. Cotangent. Now, cotangent, it kind of goes with tangent. It's the reciprocal, but we talked about it in bell work. Which 2 quadrants did we want to live in to make a continuous cotangent graph? 1 and 2. That's the difference here. That's not the same for tangent. Tangent was 1 and 4, but cotangent, we're going to live between 1 and 2. And so my range for a cotangent graph is 0 to pi. That is different than tangent. Sine goes with cosecant. Secant goes with cosine. But tangent and cotangent don't have the same quadrants. All right, so if we were to just sum up what we've said, sine, cosecant, tangent, all of those are negative pi over 2 to pi over 2. You don't have to write this down. You should know this already, but I'm just putting that out there. Okay, those three live in those those two quadrants. If we're doing cosine or secant or cotangent, it leaves between 0 and pi. That's a 0. Oh, yeah, much better. 0 to pi. Okay? Let's do it. Inverse cosecant of 2. This question right here, inverse cosecant of 2, is the exact same question as sine of what number is going to get me what? 1/2. That's what this is asking. So don't let this bother you. Inverse cosecant of 2, that is like saying, when is the y value going to be 1/2? When is sine going to get me 1/2? Which two quadrants am I looking at if I'm doing sine? 1 and 4. It's positive, so which quadrant do I really care about? I'm in quadrant 1. Where in quadrant 1 is sine going to be 1/2? Top, middle, or bottom? The bottom one is 1/2. That is at pi over 6. That is pi over 6 if you looked at a unit circle. Good there? Try the next one. A little bit tougher. It looks ugly. Don't let the ugliness throw you off. Read through all the garbage and think about what angle they're asking for. Arcsecant of negative 2 radical 3 over 3. Think about it. Here we go. If we're doing arcsecant, that is the same question as the cosine of some angle is going to get me this ugly garbage. Which two quadrants are we living in if we're doing cosine? 1 and 2. Which one do I really want if it's negative? 2. I'm really in quadrant 2, so I'm thinking about in that one. I want cosine to get me that. That's really bad. I've never done that one before. I've never gotten 3 over negative 2 radical 3. What do you think that really means? This is the same thing as radical 3 over 2, because what they did here is they already rationalized it. If I get this right here is 3, because radical 3 times 3, and those two things would cancel. Oh, yeah, it's negative radical 3 over 2. So where on my unit circle is cosine negative radical 3 over 2? That is at 5 pi over 6. Last one, arc cotangent of negative 1. Think about it real quickly. Get an answer. Which quadrant am I looking at if I want cotangent? 1 and 2. It's negative, though, so which quadrant? Quadrant 2. When is x over y going to get me negative 1? 3 pi over 4, because it's that spot right there where it gets you negative radical 2 over 2 and radical 2 over 2. Oh, yeah, if I do x over y, it's going to get me negative 1. Questions on that one? Yes, ma'am. You could say tangent's negative 1, but remember, we're looking in quadrants 1 and 3. Like, none of this part where I write it out, do you have to do that. That's a mental thing. And so, yes, you could say that is the same thing as tangent, where the tangent of what angle is negative 1. But specifically, you would want to look in quadrant 2. Does that make sense? If that helps you to write it out, do that. All right, let's do this next part. So I'm going to keep using that idea. We're using our calculator. And in theory, you should think, oh, yeah, it's super easy. You got to think a little bit here. Not a lot, but a little bit. Inverse secant of 3. Where on your calculator do you have an inverse secant button? You don't have one. You wish you did. You didn't. So which button do you think we're going to use instead? Inverse cosine. But I don't want to do the inverse cosine of 3. I want to do 1/3. Because think about what this question is really asking. Inverse secant of 3 is like saying the cosine of what angle is 1/3. That's what that's asking. because, oh yeah, the reciprocal. So I'm doing the inverse cosine of 1/3. So in my calculator, I'm going to go second cosine 1/3, 1.23. It did say go to 2 decimals. Make sure you're in radians. I'm already in radians. Make sure you are. 1.23 is that answer. Okay, so if I'm doing cosecant of -4, that is like asking the question, when is sine of some angle equal to -1/4? So what button am I using in my calculator? Inverse sine of the reciprocal. Inverse sine of -1/4. So again, in my calculator, second sine, -1/4. We're doing the reciprocal. I want to find the reciprocal value. My answer is -0.25. Makes sense so far? Then we get stuck on quadrant or on number 3. So understand why it's been so easy so far. So far it's been easy because secant and cosine, they live in the same quadrants. Cosecant and sine, they live in the same quadrants. But if I do the same thing with cotangent, I don't have a cotangent button. What button am I going to use instead? Inverse tangent. I'm really answering the question, tangent of what value gets you -1/2? That's the question that inverse cotangent of -2 is asking. It's saying, where is y over x that reciprocal? So if I'm typing this into my calculator, I'm going to do theta equals the inverse tangent of -1/2. That's a little bit tougher than that, so don't get stuck here. Stay with me. Inverse tangent of -1/2. I get -0.46 radians. -0.46 radians. Which quadrant is that in? Where's inverse tangent going to live? Which 2 quadrants? It's going to live in quadrants 1 and 4, but tangent is negative, so which quadrant is it really in? 4. And so what we've said is that this angle is like right here, -0.46. But my question asked about inverse cotangent. So which quadrants am I living in if it's inverse cotangent? I need to be in 1 or 2. And which one do I want if I want to get a negative value? I need to be in quadrant 2, but that's not what quadrant I'm in. I'm in quadrant 4. How do I change this answer that we got in our calculator and do that same angle here in quadrant 4? Say what? Yes, I'm adding pi to it. I want to go a half circle around. Okay, it's like if I did this in easier numbers. Let's say this was -20 degrees. Well, if I want that to be here, I would add 180 degrees to it. -20 plus 180, oh yeah, that would get me 160. It's the same thing, but it's in radians. If I want to go all the way around the circle, I don't want to be in that quadrant anymore. I want to be in the second quadrant. Well, the way I do that is I take the angle that I had and I add pi to it. Because if I add pi, that's 180 degrees to it. They are complementary angles, supplementary angles. That's what I was looking for. So pi, then plus that guy that I got right there. So that thing plus pi, or however you want to do it. That is the value I wanted. 2.68. That is the angle. And the reason I had to do that was because cotangent and tangent do not live in the same quadrants. Make sense on that? It's a little bit strange. Friday, Mac.